This is AP Calculus 116, the Intermediate Value Theorem, or you might see it abbreviated IVT sometimes. The Intermediate Value Theorem is an existence theorem. It just tells you something exists because of the conditions of the either equation and the interval that we're talking about. It doesn't tell you what the answer is. It just tells you that there has to be an answer there that fits the circumstance. So here's what it says. If f is continuous on a closed interval AB and D is a number between f of A and f of B. Now remember, if your interval is AB and you plug A into the function, f of A is the y value of the ordered pair you get when you plug A in. Okay, if you plug B into the function, f of B is the y value of the ordered pair that you get. Okay, so there has to be D, a number between those two y values, f of A and f of B. Okay, then the intermediate value theorem guarantees that there is at least one number C between A and B. So C would be an x value between A and B, where f of C, the y value we get when we plug C into the function, equals that D value, the number that was between these two y values. Okay? So if you look here, I have a little picture just that kind of shows you what they're talking about. So we're talking about this closed interval from A to B. So the portion of the graph we're talking about is just this portion right here. We're not talking about anything to the right or left of that section in the graph. And then our closed interval goes from A to B. And they're telling us that there is a D value, a y value between f of A and f of B, where if we plug the C value in between, that C value is between A and B, if we plug that into our function, that f of C value will equal the D value. That's all it says. It just says that there's a number that exists with that condition. So how do we use the intermediate value theorem to solve problems or to show that something exists? Here I have two examples that are asking you to show or to find a value based on the intermediate value theorem. In the first one, they tell you that f of x is continuous on the interval -3 to 2, and then they give you a table of values that would be on that function. Okay, and then they ask you to use the intermediate value theorem to show that there is a point in f of x where f of x crosses the x-axis. Now, they're wanting us to show within this interval, is there a place where it crosses the x-axis? Well, this is pretty simple. There are a couple ways you can do this. You could graph the ordered pairs and look at it. They're telling you that it's continuous from -3 to 2, for the x value is -3 to 2. So if you graph those ordered pairs, and I'm going to do a really simple graph right here. So here's a little coordinate system. I'm just going to graph those ordered pairs on this. So -3, -4 would be about right there. -2, -1, 1, 3, 2, 5. Now, since they're telling us that this function is continuous, we know that the curve is just going to go through those points and it's never going to have any breaks or gaps in it. We can draw it without lifting our pencil. And so if they ask us to show that there exists an f of x where f of x crosses the x-axis, well, we know that's going to happen about right here, because it's continuous. They tell us that. Now, we don't know what the function is doing. There's no way we can tell exactly where that value is. That value, when I draw it, when I draw the basic graph, you know, it looks something like this and that, but who's to say that it couldn't do this before going up like that? We don't know exactly what that graph looks like. All we know is there's at least one point where it crosses the x-axis. There's at least one point where f of x equals 0. So we don't know what's happening between all of these points. We just know that if the function is continuous, then it has to cross the x-axis to be able to get up to these ordered pairs. So that we know is an existence theorem. We don't know what it is. They're not telling us how to find that number or how to find that c value or d value, but they're asking us to use the intermediate value theorem to show that it does exist. In the second one, if f of x equals x squared minus x minus 12, on the closed interval 3, 5, find c such that f of c equals 0. So in this one, they're asking us to find the x value between 3 and 5 where the function equals 0, where f of x equals 0. Now, if f of c equals 0, basically what they're telling us here is that the y value of the function is 0. So they're telling us we need to set the function equal to 0. So if I do that, I learned how to do this in algebra. We would factor. We would set each factor equal to 0. We would find the x values where that happens. Factors of 12 that subtract to give you 1. That would be 4 and 3. We have a minus 4 and a plus 3 because this tells us the signs are different. If I set both of those equal to 0, I get x equals 4 and I get x equals negative 3. And they're wanting us to find the c value within this interval. Well, it appears that we have two values, but they have to be within that interval. That's what the intermediate value theorem says, that we have a c value between a and b, where that y value exists, okay, or the f of x value exists. Well, which of these numbers is between 3 and 5? Hopefully you're saying 4. So this one needs to be thrown out because it's not within the interval. There's nothing we can say about this one because it only tells us that it's continuous within this interval. It doesn't say anything about what's happening outside of that interval. So we can't assume anything. All we know is that the one place where it happens within the interval is at x equals 4. In this example, it's telling us that f of x equals 2x squared plus 3x plus 5. We have a closed interval, 1 to 4, and they want us to find the c value so that f of c equals 19. So in this one, they want us to show that there is a c value within this interval where that function will equal 19. So what I have to do is I have to set that function equal to 19. So 19 equals 2x squared plus 3x plus 5. This is some algebra we haven't reviewed yet, but if you have something like this, in order to solve that, you've got to get it equal to 0 first if you don't want to complete the square, right? I don't like completing the square, especially when I've got some things here that are going to end up being fractions. So the easiest thing to do is going to be to get that 19 on the other side, get it equal to 0 and factor. So we always want to find the easiest method. And then with this one, there are no common factors. There's nothing we can take out of all three of them. So when we factor this one, we need to look for key numbers by multiplying 2 times 14. 2 times 14 is 28. So now what we're looking for are factors of 28 that subtract to give you 3. So if you think about that, factors of 28 that subtract to give you 3. Well, 7 times 4 is 28, and 7 minus 4 is 3. So that would work. So when I set up my two binomials, once we have that, we set that equal to 0. We set each factor equal to 0. So 2x plus 7 equals 0. And x minus 2 equals 0. And if I solve that, here I'll have negative 7 halves, and here I'll have 2. And then we need to determine, can we keep them both, or do we need to throw some of them out? So, now sometimes you'll have more than one answer. There's nothing that says you can't have more than one answer. We're just showing that at least one answer exists, right? So you might have two answers sometimes, that's okay. But you do need to check within the interval and make sure they're in the interval that they gave you, because we don't know what's happening outside that interval, only what's happening inside. So if you look at this, the numbers that we get for our c values, they have to be between 1 and 4. They can't be outside of that interval. So negative 7 halves will have to be thrown out. It's not within the interval. 2 is within the interval, so we can keep that. Now, Is it possible where you might get some answers that appear to be correct, but then they're not within the interval? Sure, that happens sometimes. You might get one where you have to say it does not exist because there is no number between those intervals.